In this video, we are talking about geometric relationships of plane figures. So before we jump into these problems, let's talk a little bit about the difference between shapes and lines. So lines are one-dimensional figures, and what I mean by that is that they only go in one direction. They either go across or they go up and down. Okay? And when we do this, like for example, they can be measured in inches or feet, but basically if we have a shape that's, I don't know, 3 inches, there are 3 1-inch segments lined up next to each other. So let's say this is 3 inches. By contrast, if we have a rectangle or a square, that's a 2-dimensional shape. And what that means is it goes in 2 different directions. It's going across, but it's also going up and down. And when we talk about the area of shapes, they're measured in inches or centimeters or meters or whatever unit of measurement you're using, squared. And what that means is if you have 1 inch squared, that means you have 1 inch going up and down and 1 inch going across. So when we say something is, like for example, 20 inches squared, that means we have 20 of these little squares all bunched up together in one shape. So that's why when we say, or when we figure out the area of a shape and we say it's 4 inches across or 4 inches deep and 5 inches across, we have 1, 2, 3, 4, 5 inches going across and 1, 2, 3, 4 inches going down. And if you count all of these 1-inch squares, we have 20 square inches. So that's why when we calculate area, it's 20 inches squared. So what that means is when we're trying to calculate how much something grows or how much something increases, like let's say for example, let's erase this over here. We extend this shape, we double the length of it, okay, or let's double both parts of it. So let's say we double this side to 10 and we double this side to 8. Okay, does that mean that the area also doubles? Not quite, because as you can see, now we have another 20 over here and another 20 over here and another 20 down here. So even though the sides double, the area actually increases by 4 or 2 squared. So just like how if you have a square that is 2 inches, the area is going to be 2 squared or 4. So when we lengthen the side of a shape, we're actually squaring it or adding an exponent of 2 in order to figure out how much the area increases by. So let's look at number 1. So for number 1, we have Ken draws a circle with a radius of 5 centimeters. He then draws a circle with a radius of 10 centimeters, so a much bigger circle, or a circle that's twice as big because 5 times 2 is 10. How many times larger is the area of the second circle? So remember, even though the radius increases even though the radius has been times by 2, the area is going to be increased by 2 squared because we're talking about area. So that means that the area of this bigger circle is 4 times bigger than the area of the first circle. So for number 1, the answer is 4 times larger. Let's go to number 3. Toshi draws a square with each side measuring 6 inches. Okay, he then draws a rectangle with a width of 6 inches and a length of 12 inches. So the width is still 6, but now the length is 12. How many times larger is... Nope, sorry, I was actually reading number 2. Ignore that for a second. So the first part was right. You have an area with 2 sides that are 6 inches each. And then no, sorry. Wow, my eyes are skipping around. That's what happens when you get old. Okay, so each side is 3 inches. And then he draws a second square that is 6 inches on each side. So that's where the 6 came in. So in order to find out how much larger the side is of the new triangle than the side of the old triangle, we're going to divide the side of the new triangle by the side of the old triangle, and that is 2. That means the side is 2 times bigger. But if we want to figure out how much bigger the area is, we are going to square that increase. So we have 2 squared, and that means it increased, or the area increased, by a factor of 4. That means of these little triangles, there's 4 of them inside of this new new square. Why am I saying triangle? They're squares. Okay. So that is the answer for number 3. It's 4. Okay, let's look at number 5. Heather is using 100 tiles that measure 1 foot by 1 foot, so 1 square foot, to cover a 10 feet by 10 feet floor. Okay? So the tiles that she's using, she has 100 of them, that is 1 foot by 1 foot. So take these little squares and just cover this entire place with it. Okay. If she used tiles that measure 2 feet by 2 feet, how many tiles would she need? So what we're going to do is look at our new tiles, which are 2 feet by 2 feet. And we're going to see how much bigger these tiles are. So we're going to say 2 divided by 1. So it's twice as big. So what we're going to do is square it to find the new area, or how much bigger the area of the tiles are, and that's 4. What that means is we need 4 times less tiles than we used to need with the 1-inch tiles. So what we're going to do is say 100 divided by 4, and that is 25. So now instead of needing 100 1-inch squared tiles, we only need 25 2-inch squared tiles, or feet, not inches. Okay, so that is number 5. Okay, so for number 7, it gives us a square and a rectangle. So the first square is 2 by 2, and the rectangle is 4 by 8. And it is asking how many squares will it take to fill the rectangle below. So what we're going to do is find the area of the square, which is 2 times 2, and that's 4, and find the area of this rectangle, which is 4 times 8, and that's 32. Now what we want to do is divide this area by the little area to find out how many of those we need. So 32 divided by 4 is 8. So we would need 8 of those tiles in the rectangle. So 8 is your answer. And that is it for this section. Hope that was helpful. Next video will be chapter review.